Okay, what a great first session, and now we roll into our second session. It is my pleasure to introduce Jared Curtis from Existing Conditions. Jared, take us away. Thank you all for sticking with us.
Yeah, thank you, Eliza, and thanks to all of our viewers and speakers for joining today. And welcome again to the second annual BAC Talks. As you know, today's a day-long series of forward-thinking discussions, so I really can't thank you all enough for participating, engaging with the other viewers and speakers. It's been a lot of fun so far. As Eliza mentioned, my name is Jared Curtis. I'm president of Existing Conditions, and Existing Conditions is one of the leading providers of building documentation and existing condition surveys in Massachusetts, but in the country as a whole. A brief background: prior to my role at Existing Conditions, I was Director of Capital Markets and a real estate advisor for Sotheby's International Realty, mostly focusing on real estate development and acquisition services to multifamily developers and housing owners in the Northeast United States. I'm also a proud graduate of Cornell University's Architecture School, so it's great to be in an event with many architects and people with architecture backgrounds. So jumping straight to it, today's talk is titled Building Documentation Technologies, the History, the Future, and Beyond. And over the next hour or so, I invite you to listen in on two very unique and trusted perspectives in this really fascinating space. I'm honored to be joined today by Amr Rafat, MArch class of 2010, Vice President of VDC and Technology at Wendover Construction, along with Kurt Yeagen, who will be joining us on a remote basis, BAC alum and founder of Existing Conditions and my business partner. Kurt and Amr will each have a brief presentation of the history of building documentation, how the tools and methods have evolved from antiquity and tape measures to the advanced tools seen on site today, all the way to the state of the industry in the future, including things like drone mapping, virtual and augmented reality, and robotics. And following those two presentations, Amr and I will break off for a discussion and a Q&A. So without further ado, please allow me to introduce my partner, Kurt Yeagen. Kurt is the founder and CEO of Existing Conditions, which was launched in Boston nearly 25 years ago. Kurt became a licensed building contractor in 1992 and managed construction of numerous large-scale projects in Rhode Island. And interestingly, prior to his private sector work experience, Kurt spent 13 years as an engineer in the US Air Force, specializing in existing building analysis and contingency preparedness. Kurt also attended the BAC and has been appointed chairman of the Boston Society of Architects 3D Laser Scanning Committee. And with that, Kurt, the floor is yours.
Thank you, Jared. And I'd like to start off by saying thank you to the BAC for organizing this event. We are very excited to be here with you, and we really appreciate the chance to speak to you about what we've been doing in Boston and nationwide for the last 23 years. I would also like to thank the BAC community for joining in on this meeting. We realize that everyone's busy these days, and the last thing anyone wants is another online meeting. So we appreciate you being generous with your time and joining us. What I'm going to talk to you about today is not only the history of building documentation, but also how we found that we entered the market at the correct time when the technology was mature enough to be efficient to use and be profitable. Going back to the very beginning of the built environment, the tools that builders, architects, designers used were contemporary for their time. They were using the best technology available to them, which is what we do today as well. Some of the early tools consisted of rods at a specific length, or chains of also at a specific length, or even something as simple as the average length of a man's forearm. As time goes on, technology evolves, and as an industry, we've adopted these technologies. And as it turns out today, we're at the very beginning of a new leap in technology into aerial LiDAR surveys. Let me start off by telling you the origin story of existing conditions. Like many of you here right now, in the late 90s, I was also a student at the Boston Architectural Center. And like many of you now, I was working in the field while going to school full-time concurrently. There are a lot of advantages to that, and I really liked that lifestyle. But what occurred to me that would happen over and over again, and still happens now, I observed this at working at many firms over my years at the BAC. And I found that when it came time to doing the existing condition surveys, the building measurements, it's not something that people really wanted to do very much. And what would often happen, and again, still happens today, is that you would have the most junior people sent to the field who, of course, have the enthusiasm and the excitement to do it, the energy, but they really don't have the expertise and they seldom have the correct tools. So what we would find that would happen, and it happened over and over again, we would go all the way through schematic design development into construction documents. And then we realize the column grid is off by a foot and the walls are the wrong angle and the floor to floor height's off by a few inches here. And that would translate into major problems at the end of the project, change orders, potential litigation, and just all the unpleasantness that goes along with a redesign that has to be done because of not focusing enough on providing a critical point of departure for designers to do their work. And that is a good base set of existing conditions drawings. So after seeing this happen over and over again, I thought maybe it would be a good idea to start a company that provides this one service only to the building industry. And I just thought that a professional company with some people who have a great idea, have the energy and enthusiasm and the expertise to really implement this plan and execute on it, I thought it would be a great idea. And I'm very proud to say that after starting in my South End apartment 23 years ago, we're now at a point where we measure nearly 60 million square feet per year all over the country and the world, as far away as the U.S. Embassy complex in Liberia to the Budapest Stock Exchange Palace to the New York Stock Exchange, U.S. Capitol Building, Pentagon, Stanford University. I could go on and on. I'm very proud of the portfolio that we've been able to put together. And it's not only a matter of technology, of course, because the technology is only really half of the equation. It's the expertise that you have in deploying this technology is absolutely critical. I always use the analogy with my clients that I could go to Home Depot and purchase the most expensive hammer that they sell. Doing that won't make me a master carpenter. So the same goes true for 3D laser scanning or deploying any other technology. You have to have the expertise and the skill and a solid plan and a methodical checklist and all of these things that will make you successful. You have to have those things in place. So it was an idea that was really not being served in the industry. And myself and some others identified that this is something that will help the community. It will allow the community to leverage our expertise, leverage buying equipment that may cost hundreds of thousands of dollars and that you seldom use. It allows you to call upon our expertise It allows our clients to have a set of eyes in the field that they wouldn't ordinarily have, because we're providing them with that rich data, scan data, BIM models, drawings, etc. We are an extension of them, and we are the tip of the spear on construction projects and design projects. Getting back to how we evolved at the right time, I'll give you a little bit of background on that. As the company started in the mid to late 90s, what was happening in the industry is that it was really a time when nearly all firms had adapted the use of 2D CAD, whether that was AutoCAD or DataCAD or Sun Systems or a number of others that were out there. AutoCAD, of course, being the dominant platform. It was a time when it was feasible and possible to create drawings, particularly existing conditions drawings, very rapidly. The business really wouldn't have been successful or profitable had we had to wait and draft by hand and make manual copies and things of that nature. So with the advent of CAD, we were able to produce drawings in a very quick way. We were able to distribute our workforce because we didn't have to have everyone in a central location. We could draw upon talent from wherever the talent pool was, which is another great thing that we've done over the last 23 years. So the advent of CAD was critical to the success of the company. So we were able to catch that sort of technological crest at that point, and that really helped us. Otherwise, it wouldn't have been a profitable business. The second piece of technology that came out at approximately the same time was the advent of the single point laser, the first generation Leica Distos or Hilti lasers. And that was a tool where I'm sure most or all of you are familiar with that. It's really a handheld device, takes a shot from one point to another and gives you a length or height or any other dimension that you need. And although that seems very quaint these days compared to the other kinds of technology that we're deploying, it still works. It worked then, and frankly, it was revolutionary when it came out. It allowed us to measure a large commercial or academic space very quickly because of the range of that single point laser. We still had to take paper field notes on graph paper with different colored pens. There still was that level of, we're using this technology that is available to us to interpret that into a drawing by way of this graph paper that you see with dimensions and schematic representations of doors and so forth. So that was really all that was available to us technologically at the time. Some projects that needed a bit more precision, we could use a total station that you may have seen a land surveyor use. That was helpful to us, but generally speaking, the technology was photographs, perhaps some photogrammetry, and really single point lasers and tape measures. That was the state of the art, frankly, at that time in the late 90s, early 2000s. The next major leap in technology really came out in, I would say, the early to mid 2000s. And although 3D laser scanning has been around for nearly 3 decades now, it really became efficient and cost-effective for us to use around the middle of the 2000s, 2005, 2006. That's when companies like Faro or Leica were able to produce tools that would cost, say, I know it sounds like a lot, but like $100,000 or less. Because at that price point, we were able to deploy that tool and bill it out multiple days per week, many times per month, and it's been a great process for us. Those generations and the current generations of 3D laser scanners that we currently use really allow us to get better and faster at what we do all the time. We're able to leverage more new technology along with the expertise of our staff to really provide situational awareness to our clients that is unprecedented, that has never been able to have been delivered to our clients or in the past. It's not only the scan data, the BIM modeling. As I mentioned a little bit earlier, we're really starting to really embrace drone technology, robotics, and we're very excited where that's taking us. Not only with aerial drones, but also with automated systems to monitor buildings, to measure buildings more efficiently. We know that we need to be on the vanguard of all the new technology, or our competitors will be. A few of the red letter dates, I would say, in the company that I'd like to tell you about really reflects what the staff here brings to the table. And again, what I mean by that is you can buy the best computers, you can buy the best scanners, you can rent the fanciest office, but it's really your backbone is your people, your staff, your team. And we have a team that is really second to none in the industry. I couldn't be prouder of all of them. And many of them have been with me for 22, 23 years, 20 years, and it's very unusual these days, and it's not by accident. It's because it's an exciting place to work, not only because of the technology that we're deploying, but also because of the great spaces that we get to go into and work in on a daily basis. Things like the U.S. Capitol building, or the Pentagon, or Carnegie Hall and New York Stock Exchange. It's been fascinating for me. I've learned more about architecture by working in these old buildings and seeing how they're put together, the tectonics of it, and really understanding what it takes to put a great set of drawings together. You learn that from being in these old buildings, so it's been an invaluable experience to me. As far as where are we going in the future? I've been doing this a long time, and I really feel that I've never been more optimistic about the future in this business, and there's a lot of reasons for that. The technology is maturing. We're able to deploy better, faster equipment. We're able to collect more data. We're able to do more with that data. Our clients are able to do more with that data. So it's a very exciting time. I, can remember when I was at the BAC thinking, there has to be some better way of doing this than the same way we've been doing it for 2,000 years, with some kind of a stick with numbers on it or a string with numbers on it. There has to be a better way. And it was exciting to me then, it's exciting to me now. It's something that I have a huge sense of pride in, and it's something that I really want to let everybody know about, because no one has ever said to us that it's it's a terrible idea to have really accurate drawings of your building. No one's ever said that. So it fills me with pride to deliver something to a client and know that it's extremely useful to them, and that it's going to help them with their design project, with facility management going forward, and just to create a living, breathing document that is an asset to that property.
Thank you, Kurt. Truly an incredible story, both that of where the industry has evolved to over the past 20 years, as well as your personal story and how existing conditions has grown alongside those advances. It's great to be a part of your team. So thank you for sharing that with me and with the audience. Certainly lots to touch on in our discussion format later on. With that in mind, I'd like to introduce our next speaker, Amr Rafat. Amr Rafat is the Vice President of VDC and Technology at Wendover Construction. And Amr has over 17 years of experience combining architectural, construction, and engineering expertise. And he's, as a result, an industry-leading technology expert. As VP of VDC and Technology at Wendover, he leverages the most cutting-edge technologies available, such as BIM, laser scanning, drone mapping, virtual and mixed reality, digital fabrication, and even 3D printing to streamline the construction process for his clients and his own project teams. Amr has published multiple articles on construction innovation and is a regular presenter at technology conferences throughout the country. He holds a Master's of Architecture degree from the BAC and was recently recognized as the Autodesk AEC Innovator of the Year. So with that, I'd like to hand things off to Amr.
Thank you, Jared, and thank you, Kurt, for a great presentation and perspective on how we document buildings. Really great story. Very excited to be back to speak at the BEC, which means a lot to me. It's a great school, and I had so good, learned a lot from the BEC. I love the practice part of the BEC and how it really helped us evolve as leaders in the industry and really focus on what really matters, which is building great buildings with great people, which is one of the main things Wendover construction focus on. I lead a team of virtual design construction. Most of our team is based on architectural and engineering expertise and the use of technology. I can't agree anymore with. I totally agree with Kurt that it's not about buying the latest drone or the latest laser scanner. It's really it's all about the data and how we can utilize the data. So you learn it now from Kurt how this all evolved. Now we're going to talk about a few examples of real-time examples of applying technology on job sites right now and the future of that, and how this is really helping increase efficiencies. I'm going to share my screen so everyone can see the examples. Do you guys see my screen? Jared, do you see it?
Yes.
Awesome, thank you. So a quick overview for Wendover. Wendover is a leading construction company. We build hotels, academic buildings in the New England area, modular construction, life science, healthcare, and historic preservation and hospitality. So we've been building around New England and the United States. It's 100% employee owned, and we really focus on innovative solutions and how we transform the way we build. So we'll start to talk about laser scanning and drone mapping for QA/QC on construction. So you have an architect who had a great design, and our job in construction is to really preserve that design intent and making sure that the architect perspective and vision, as well as the client perspective, has been executed accurately. A great example of that is a Canvas project, which is in Beverly, Massachusetts, only 30 minutes from the BEC Drive. And it's a modular construction project. This project was recognized globally by Autodesk for its innovative use of laser scanning and drone mapping to transform the way we build modular construction projects. As you see here, it's made out of 2 buildings, 325 units, as made out of modular construction. So what we did actually is that we had a challenge here that the first 2 floors are structural steel, and the upper floors are modular construction boxes that gets placed on site over those structural steel. So you have 2 types of structural systems here. The modular is made out in a factory in Canada, and the steel is being made on site in real time. So what we did actually to make sure that all these boxes, when they arrive on site, they're going to fit perfectly above that steel. What you see here in red boxes is where the factory was planning on putting those vertical MEB shafts to take all the pipes, the plumbing, all the pipes that's coming from all the floors in the from the steel up. And what you see here in yellow is the clashes we detected through our constant laser scan. So every time we erect steel in different phases, say that part erected first. After we erect steel, we capture the data with the LiDAR, with a laser scanner from the air, and complement that with a laser scanning from below to capture a highly detailed information, point cloud of that. And then we do a real time on the same day overlays to detect overlays with what the factory in Canada is planning actually to put their vertical shafts. And we found with that in real time few clashes that, if they put the vertical shaft in the box, the modular box, and they ship it here, it's going to hit some steel, because every inch make a difference on the steel that gets erected. So we made sure this way to detect a dozen of clashes in real time, communicated to the factory so they make any necessary adjustments. And with that, we made sure that all the boxes, when they arrived on site, we had 0 clashes on site. And that's a mixture of drone mapping, laser scanning, and BIM data. Plus, of course, the MEP BIM coordination, which you've seen here on the screen. These are the clashes we found, that steel is hitting the vertical shafts. Time is critical here. When it gets communicated in real time, it can save thousands of dollars. And what's more important, actually, than even the cost, is the time. Because imagine if you have a box arrive on site, you will have to make all these edits to it, and that delay in the schedule. With this, Wendover were able to shed 3 months of the schedule, which is great to deliver a project earlier and on time. This is where how the box is getting placed on site, as you see here, with 0 clashes. This is another example of how we used laser scanning on site. With the Wendover VDC team scanned the facade, and as you see here, after placing all the different boxes, we wanted to check the blumminess of the facade. So we end up preserving a beautiful, smooth facade, preserving the design intent. You know, the boxes can have some blumminess to it when they get placed. So what we did is that we laser scanned it. We dealt with the facade as if it's a contour map, and we had some spot elevations to make sure that we communicate that in the real time to the trade partner working on the facade, to making sure they have all this information, all this data, so that we end up with a smooth facade that has no blumminess. This is another way of using data on site in real time, communicated to the field team, so they can make any edits and make sure we end up with a good quality project. This is a 13-acre site in Gloucester, Massachusetts, where this was during the COVID surge back in April. And we did regular QA/QC overlays between drone mapping with ground control points and laser scanning, so we can communicate, keep track of construction progress, and making sure our super, for example, has data about, it's more than an eye in the sky. It can capture data for stockpile analysis, which the superintendent can really calculate how much dirt coming in and out of the site. Regular overlays, as you see, simple 2D CAD overlays over these accurate drone mapping, so we can see, we finished that, and making sure that the design intent is progressive. In a 13-acre site like that, it gives a very integrated perspective for the superintendent and the project manager to really help manage the project and streamline decision making. During the COVID, we had superintendent working on site while project managers working remotely. So weekly laser scans and drone maps have really streamlined decision making and helped the folks communicate effectively between the field working on site in an essential project like that. That was considered essential by the Commonwealth. It has to go because of the residential components to it. So we can combat the need for residents and affordable residents in Massachusetts, while the project manager working remotely. So communication, it helped with enhanced communication. Another project, this is a project that got set up on site in only 8 hours with modular in New Hampshire. So in order to put these boxes in 8 hours, you really need to make QA/QC again. Quality control is the key here. Our job as VDC experts is to have no surprises on site. So one of the ways that can mitigate that and help support that is really laser scanning. So you see here spot elevations confirming that the slab that got put there is flat within half an inch. It has to be within half an inch before we put all those boxes. How to confirm that? With laser scanning. As you see here with the spot elevations, with that we're able to set up this building, as you see here, only in 8 hours. I'm gonna play this is the timer here. Only in 8 hours, the setup going there. This is the slab that we actually laser scan, making sure it's flat within half an inch, so all these boxes put on it like a Lego. Wendover has been a leader in modular construction and is really the go-to for modular construction in the New England area. Robotics and automation. So we talked about laser scanning, how we use it on site. Wendover wanted to transform the way we do laser scanning to on site. So we partnered and collaborated with Autodesk and a software robotics company, FCML, to help transform the way we capture data on site. We helped collaborated to create a robot called Oliver, which this is one of our job sites at Endicott College. As you see here, it's going in a slope. It can do autonomous laser scanning from point E to point B. Up until this moment, experts and architectural graduates and VDC experts go stand for 12 hours or 14 hours to scan at each round. With this one, we were able to automate this process, especially really used in very cold weather and environmental hazard areas where you really is asbestos and other things that you don't want to be around. So the robot can go scan. It has a self-leveling, and it can really automate this process. It can also do autonomous laying out of utilities and walls on site directly from Revit, from BIM. As you see here, it's spraying on the walls and the utilities directly from the BIM. So this was a great collaboration between Wendover, Autodesk, and FCML, which is now Nextera Robotics. This is another way of how we use robotics to automate these processes and really help save time and increase quality. In the same time, it's not replacing anyone, it's really helping our teams to focus on what really matters, which is capturing the data, working on the 3D models, and be more productive at what we really should be doing. Another project related to BIM data is this is a building in Gloucester. We needed to create trusses. And as you see here, we were able to create those 975 trusses using cold formed steel with BIM data and scan the data on site. This is the dynamo model we created to create 975 trusses only in 15 hours, as you see here. This is another way of automating processes and making sure we can create a large mass of structural elements or walls in a very short time. And what we actually at Wendover did, which was unprecedented, is that we actually added another layer of mixed reality to this to assemble it on site. So I'm going to show you here. You have this. We collaborated with Hologram, which is an Australian-based technology. Hologram helped us in assembling those. Each truss is made out of 8 pieces. We're able to assemble all these 8 pieces with guidance from a hologram. You know, when you assemble furniture, it's guiding the assembly of the furniture of the trusses through mixed reality. What Hologram does is that it guides our field team to assemble the 8 pieces step by step very quickly. With that, we're able to cut the time by 70%. We were able to assemble 900 and almost 1,000 trusses in 3 days only with 1 person versus 7 days with 2 persons. So cutting time, safety, increasing safety because it's guiding 1 person while maintaining social distance. Also, this was during the COVID surge. This is a great example of mixed reality with digital prefab. Few examples of how we use laser scan on site for QA QC. As you see here, this is an Olympic-sized swimming pool. We laser scanned it during construction. On the same day, we do QA/QC overlays. What you see in red is the scan. See in blue is what it should be from the model, from the architect. As you see here, few discrepancies gets communicated on the same day to the field teams. They make the necessary adjustments on the next day, and then we're preserving design intent, making sure what's built is exactly what's designed. Same thing here on the first floor, same project. We scanned all the underground piping before we pour concrete. The laser scan is every 70 meter, only 3 millimeter off. So it's really this is accuracy we need on site. Regular QA/QC, first floor plan or overlay with the underground piping led to finding more than 10 pipes outside of walls. In the same day before pouring concrete, our team make the necessary adjustment to these pipes, so to make sure that every pipe on the underground meet its intended location on the first floor, which is for a project that size, it's thousands of dollars of savings and time savings with laser scan. Additive manufacturing. This is one of the oldest libraries in the US, the Boston Athenaeum. What we did is that we've been utilizing laser scanning a lot to document our historic preservation projects. And we take that to actually help with digital prefabrication, breaking all the different pieces we scan, create a digital prefabrication model. This is a 120-year-old building north of Boston. It's a historic building that we wanted to renovate the entire facade for it, which was deteriorating. What we did is that from the laser scan data, we created a highly detailed digital prefabrication 3D model, as you see here. And then from that model for these different elements, this is just one example, we're able to 3D print those pieces with a material that would stand for another 100 years with no maintenance needed. As you see here, the level of details carried from the laser scan to the 3D printing. Also, we utilized mahogany wood for other pieces. As you see here, this is a simulation of how the 5-axis router would cut all these different pieces. And this is the result. So really, this all comes from laser scanning data that we helped us with the digital prefabrication modeling. All these panels were done in digital prefab from laser scan to BEM, as you see here. So these beautiful rosettes that was done by hand 120 years ago, we're able to replicate exactly the look of it from the laser scan to the BEM digital prefabrication model to the making of it very accurately, as you see here. Everything above that column line, including the panels, the rosettes, everything was digitally prefabricated by the Wendover team. That's how we been transforming historic preservation, making sure that highly accurate replicas can be done. Fast-track projects with modular construction. Many schools, actually several schools in New England, reached out to Wendover to help them with temp dorms so students can come back safe last September during the COVID surge. A project that would usually take 6 months, 7 months, we did it in 2 months only. And one of the ways we did that is laser scanning. On the first day we go there, we have a drone mapping and laser scanning the site, helping us with capturing high-res data of the site. This is Phillips Exeter Academy. This is one of the great schools in the Boston area. We're able to, it's an urban site. We're able to laser scan it and LiDAR scan it with a drone, a process that takes weeks to do. It was done in 2 months to get a permit for fire chief. The fire chief sees the animation, which is on a drone map site. They say, oh, my fire trucks can go in emergency very smoothly. So they approved really working on 2 towns. This project on 2 towns. So laser scanning and drone mapping really helped expedite processes like that. The final documentation of buildings. These boxes made out of in Canada. We document the site. We documented while it's being made, and we deliver the client as-built documentation of it. So 10 years from now, the client can go to each box or each apartment, see how it was made, what's behind ceiling, what's behind walls. And finally, this is a study at Sandon Prep in New England. The light was too bright during night games after Wendover finished this state-of-the-art sports facility. Light was too bright for one of the neighbors here. it looks like noon at 10 p.m. for him. So what Wendover did is the school reached out how we can resolve this unforeseen condition. What we did is that we wanted to block the light and support that neighbor and help resolve the issue quickly. What we did is that instead of going with shades and trees and put them physically, we did a drone map the entire site, including the neighbor house, and we used the virtual reality and 3D Studio Max with the drone map site to help do studies very quickly on a couple of days on how we block the site. We tried evergreen trees, we tried different methods, and we knew from this result how much shade we need to order to make sure we block that light virtually. If you don't have this technology of drone mapping and virtual reality, you will have to go at 10 p.m., turn on the stadium lights, and get physical trees and try to block the light or the screen. This is how we give feedback to the field team where to exactly place these elements to block the light, and that's what they did. So this is a few examples of how we combine different technologies: laser scanning, drone mapping, additive manufacturing, robotics, automation, virtual reality, to offer real solutions on site to resolve the problems even after the project is done. Thank you so much.
Thank you, Amir. That was really, really fascinating. So many great points to discuss. Can't wait to dive into the details with you and pick your brain about where things are headed, how you're looking to be a part of this part of the action. A quick preface for the audience: at this moment in the talk, we're going to shift gears into a discussion format between myself and Amir, and we're going to discuss some of the major topics at play in the world of building documentation and construction technology today. If we have time, we'll also take some questions from the audience, although I did have a few that were submitted in advance, and just trying to be cognizant of time since we'll be handing off the program to Dr. Neri Oxman after this. So Amir, let's start with a prompt that I'm sure both of us hear quite frequently from our colleagues, from our friends. With so many changes in the construction technology and real estate technology landscape, what are you most excited about, and what is Wendover most excited about?
You bring up a great point, Jared, that it's changed quickly and there are always new technology. It's a matter of we focus on the effective solutions. All the work we've been doing is really based on solutions, real-time solutions to support the challenges on site. What I'm actually more very excited about is that the potential for these technologies to help with educating the new workforce and the new the students. So there's so much here to inspire and learn from what we've been doing, because not every, as if you may see here, not every project has the same solution. So the way we can adapt with different technologies to offer solutions, different solutions, is really the power of technology, that it is not one solution for all. So what I'm excited about is that next month we'll have a different challenge, we'll have a different solution. But what's really common between all of these is the basics, which Kurt talked about, and I always loved when we did the BAC draw by hand, because this starts the basic of how you can use technology. The reason how we excelled in using these different technologies to support the clients and support projects is that we know the basics and we also build upon it. It's an accumulated project. When HoloLens came, we thought, oh, that is the latest, greatest thing. When the automation came, it was always something new. And what we really need to do is to make it an accumulated process. So that's my opinion. It's an accumulated process, building upon what we learn and mixes them together to offer real solutions.
I'm laughing to myself because we did not coordinate answers to this question, but I have such a similar perspective on this, that there's so many incredible, exciting individual technologies being implemented today, both for builders like you, but also for architects, for building owners, developers, engineers. But similar to you, I see the cultural shift in the industry towards technological adoption and interdependence among these different groups. It's long overdue. And while that's not itself a single technology, I see that as as the most important factor going forward. In that, for myself and for the team at Existing Conditions, there are a number of specific technologies to be very, very excited about, and you demonstrated some of them, whether it's how quickly drone mapping is advancing, different ways to gather and process laser scan data. And as a result, we've never been more excited about the future of both our niche as a building documentation company, but the business as a whole. Technology is maturing on the software side, faster hardware and ability to collect more data on the hardware side. We're able to do more with that data. We're able to present it in more accessible ways on cell phones, on iPads, and so on. But the most exciting shift from where I sit is almost, I call it like a macro technological trend. And what I mean by that is Existing Conditions was fortunate in the past year in that it's been a remote distributed workforce since it was first founded. And while many companies in the AEC industry have centralized offices for very good reasons, we had been a distributed team from day one, largely due to the fact that we're out on site so often. So for me, as the country and the industry and the world actually have shifted towards hybrid and remote work in the past year, their attitudes towards services like ours or abilities at Wendover have changed significantly. I think people's comfort level with new forms of communication, new means of technology, new ways to produce housing or document a site has changed just so much. And the idea of getting out on site without actually getting out on site is no longer a foreign concept to architects and owners and developers and builders. And that's a major shift, right? And collaborating with the best professionals who are the best fit for your project, no matter where they call home, no matter whether you've even ever met them face to face, is no longer really a limiting factor. So we're in this situation where all of these technologies are suddenly less intimidating for our partners. And whether it's you or Existing Conditions, when we get called out on the site at the beginning of a project, we can set the basis for all these other teams to do their work. There's no more expectation for every member. In the robotics example you showed, there's no expectation for every member of the design team to get out on site in February just to do so, right? And it's leveled the playing field for those who aren't able to do so, whether that's for accessibility or economic means or any other impetus. So really interesting that we're seeing on the same page there. But I would like to shift gears a little bit, being cognizant of time. This is a question that was submitted by an audience member who's an architect in the greater Boston area. And as an architect yourself, I'd be really curious to hear your thoughts on this. They wrote that the discipline of architecture is often described as one of the highest forms of art, the mother of all art forms by some art historians and architecture writers, but it's also often approached as a hybrid of art and science, beauty and structure. How do you see the field of architecture itself changing? You touched on this a little bit with your education comment, but how do you see the field changing as more of these technological advances become commonplace in the architecture office of tomorrow and the job site of tomorrow?
So that's a great point, and it's really I think so much about that question is great, because it's architecture and design is really not only forming buildings, it's forming the experiences within that building. I started my career working with a great prominent architect, Peter Shermaeff, when I was studying at the BAC, and he's a designer of the New England Aquarium and the National Aquarium in Baltimore. We designed the aquarium around the world, and I was fortunate to work with him. You would find all these designs really forming experiences. So for someone to design a building, not just a machine that will interact with people, you really need that art, because art is understanding of human experiences. Art is how people will be comfortable with that building. What I've seen lately with our modular projects, for example, with the increase of technology, it helped us coordinate. Modular doesn't have to be a shoebox anymore. It can be a very offering our design partners to design beautiful, flexible buildings. And the reason for that is the technology we have in BEM to coordinate these complex MEP systems. It doesn't have to be straightforward box. So with that, it's offering architects, our architects, to design modular projects with all the benefits that comes with modular in a very flexible way. And that's a form of art. So it's always a mix of science, which is the data we have. It's a lot of complex MEP systems, modular boxes, manufacturing, really. It's more about the data part of this than the design, because you give us data, because and prefabrication, which is the future, in my opinion, because it saves time on site, cost, everything built in the factory was very high quality. And the prefab, even for historic preservation, all these different elements were done in a factory that we did it, the scan and the model. So it's about data, and you have the design. In my opinion, the design is more about the art, about efficiencies, about the vision from the architect on how these buildings will come, which actually have a reflection of the community and the client. In the same time, we have to preserve public safety, public good, because it's not only, this building is not only designed for the client, it's only designed for the public. So my father is an architect, my brother is an architect, and I'm coming from an architectural family who really and my mother is an art teacher. So you can see how in one family, art with architecture is really a mix. We are probably one of the very few professions that has both in mind in the same times. You have to go parallel, art and science. Science to make it work and getting built and safe for everyone, and art to make it livable spaces that can grow with the environment, not take from it. So I think it's always has been a part of this, and only successful buildings will be having, the architect would have in mind these two things so that they become successful buildings, spaces.
That makes so much sense to me. It makes me think of when I started architecture school at Cornell, the professors made a very intentional decision to have hand drawing remain the core of the first year studio environment, to maintain that aspect of art and handcraft, and not throw the students into the world of technology too quickly, to have them pump the brakes a little bit. Every aspect of the first two studios I undertook had hand drawing and even hand drafting as central elements, despite the fact that software like Revit and Rhino and AutoCAD was already widespread in many offices. And I could see the architecture school, and therefore the architect of tomorrow, looking very different, but also looking very similar. And what I mean by that is that if you walked through the BAC, a classroom at the BAC or at any other top architecture school in the area, you'd realize that with advanced tools like 3D printing, digital visualization, parametric design like Dynamo that you represented, students today are exposed to the impacts of technology from the very beginning. But at the same time, being an architectural professional always meant that you had to understand the technology behind buildings, right? In the 20th century, that largely meant understanding disciplines like structural engineering, environmental systems, maybe some material science to understand how to properly insulate a building and so on. And that framework is still there, but in the 21st century, our definition of technology has changed very much. I mean, to Kurt's point from the earlier segment, at one point in the history of humanity, a chain with a specific dimension or a piece of wood with a specific dimension, that was technology. But today, instead of beams, it's more common to be managing bits and bytes, and the combined impact of the internet and globalization, or remote computing, graphics capabilities, those have redefined technology and in turn the domain of the architect. So as the industry of our built world continues to become more specialized, architects will continue to define their role depending on what their skill level and desire is. So personally, I can't wait to see what the future holds for the profession. I know we're tight on time, so Amr, I wanted to give you just a couple minutes. If you have a closing remark that you'd like to make, I'd love to hand the mic off to you.
Sure. Sure, I totally agree with you. Actually, I always believe that the use of today's technology with tomorrow's vision is the way we will move forward. One of the examples we showed is how we check the plumbiness of a facade with a laser scan. Using the technology we have today with a little bit of more creativity can really transform the way we build and raise the bar of the technology we have right now, which has limited capabilities. That's how we can push the limits and offer solutions. I'm very excited to be talking with the BAC community today, it's a great honor to really talk to this great school. And as you see here, the BAC graduates are really reshaping the future of construction and design, which is great to see. We're also hiring at Wendover. We would love to see candidates from the BAC because I know they are very innovative, hardworking architects and experts and graduates. Thank you so much.
Yeah, thank you, Amr. On behalf of Existing Conditions, for any architects, students, professors, or anybody who wants to learn more about what building documentation and laser scanning, building information modeling entails today, please don't hesitate to reach out. So thank you again for listening. This was Building Documentation Technologies, the History, the Future, and Beyond. Thank you to both Amr and Kurt. Hope everyone in the audience enjoyed these presentations of how the field's means and methods have evolved from antiquity to the advanced tools used today. Please don't hesitate to reach out if anyone to myself, to Amr, or to Kurt if you would like to learn more. We're all very happy to connect with you. And with that, I'll hand the controls back to our MC for today. Thanks again, everyone.
Okay, thank you all. And we are just about right on time, only 3 minutes over. So thank you, Amir. Thank you, Jared. Thank you, Kurt. And also to anyone else who, has participated with us today. Thank you for sticking with us throughout the day. It's getting very exciting and will continue to throughout the day. Again, if there's anything you see here today that inspires you to get involved, call to action, participate, learn more, send us an email, alumni@thebac.edu. And we are going to end our session now. We have Neri Oxman coming on at 11:30. So stand by and we'll see you just in a few minutes.